Good day, learners. In today's video, we're going to be doing the example that I showed you on the board the day before yesterday, where we first started doing work energy theorem. So you will recall that I wasn't present yesterday. I was supposed to teach you. I was actually supposed to be assessed while teaching you. So now I'm going to be doing the example that I promised to make, to do, I mean. So let's get on it. So we're gonna do this example only for today, and then I'm gonna post another video tomorrow where we're gonna be doing conservative and non-conservative forces. Okay, so let's read the question. Here we are told that in figure 4.43, a 3 kilogram block slides at a constant velocity of 7 meters per second along a horizontal surface. So this means that this 7 meters per second is our V initial. This is our initial velocity because it's already traveling at that velocity when it encounters this 2-meter patch here. And they're also saying that it then strikes a rough surface, causing it to experience a constant frictional force of 30 newtons. So here there's also friction. It's also friction of 30 newtons. The block slides 2 meters under the influence of this frictional force before it moves up a frictionless ramp or ramp, depending on which country you are from, inclined at an angle of 20 degrees to the horizontal as shown. So they are saying that the block, during this duration of its period, while traveling here, experiences friction. But then when it goes up the ramp, there is no friction there. Okay, so let's go to 6a. So the question goes like this. Use the work energy theorem to show by calculation that the speed of the block at the bottom of the ramp is 3 meters per second. We know that the work energy theorem says W net is equal to delta E K. W net is equal to delta E K. And if we expand the side on the right, we're going to get 1 over 2 mv squared final minus 1 over 2 mv squared initial. We want the velocity, we want to prove that the velocity here, the final velocity here is 3 meters per second. That's what the question wants. So this is the value we want here. We don't know our W net. Our W net can be found by calculating the work done by friction during the time the block is moving at that 2-meter rough patch, because the work done by friction would be the net work done, because there's only friction that's doing work on the block. So we know that W net in this case is equal to the work done by friction, and we know that to calculate the work done by friction we can use the formula that was first introduced to you in the previous chapter, where we say work is force. Work is a scalar quantity that is a product of force, displacement, and the cos of the angle theta. The angle theta is the angle between F and D and delta X. Take note of this. Okay, now let's substitute the values that we have. We know that the force is what? 30 newtons we are given. That's the frictional force. And we also know that the block is displaced 2 meters. And because friction is going this side and the block is moving to this side, they're going in opposite direction, and therefore the angle between them is 180 degrees. So you're going to have cos 180 degrees here. Cos 180 degrees. 30 times 2 is 60. Multiplied by cos 180 degrees, which is -1, that's going to give us -60. Right? Now we can take this -60 and put it here. Put it here on W net. As a result, we're going to have -60 is equal to 1 over 2. 1 over 2, remember we are using this equation now. So it's going to be 1 over 2, and the mass is 3 kilograms we're given. V final is exactly what we want to find. Multiplied by 1 over 2, multiplied by the mass, which is given again, and V initial is 7 meters per second. And remember, this is a scalar quantity, and we also have a square on top. So even if you put that as a negative, as -7, it would still come out as positive 49. So it really doesn't matter. And then now we take this expression to this side, to the left. So we're going to end up having 1 over 2 multiplied by 3 V final squared is equal to, we take this one and drop it down, what, negative 1 over 2. Oh, by the way, this becomes negative when it comes to this side. And then multiply by 3. And 7 squared is 49. 7 squared is 49. And negative 60 comes to this side and becomes positive. As a result, our V is going to be equal to, remember, we're going to multiply by 2. We're going to cross multiply by 2 on the right and divide by 3. And then take a square root. So here's a square root. We multiply the numerator by 2. And then that's 3. 49 plus 60. And we divide the whole thing by 3. Negative 3 in this case, because we had a negative. We have to account for the negative sign whenever we do the calculations. No sign should be left behind. And we already had a negative there too. This one. Our answer here will indeed be 3 meters per second. And that's how you would do this question. Now let's go to B. So let's read B. Draw a free body diagram to show the forces acting on the block while the block is sliding up the ramp. Label any relevant angles. So we're drawing a free body diagram. So just going to say free body diagram. And of course, this is an incline. I like to indicate an incline using the dotted line, these segmented lines here. And I put a dot here to represent the block as a single a mesh point. I mean point mesh. And of course we have the force of gravity acting directly downwards, and we have the normal force, all this perpendicular to the surface. We also have the perpendicular component of the force of gravity. We also have the parallel component of the force of gravity here. And remember, there is no friction here, so we won't have a direction for friction because we do not need to account for it. And there's also no applied force here. So these are the only forces that you would represent. And by the way, don't forget to make sure that you write your angle. In this case, 20 degrees. You might also represent it there as well. So that's 20 degrees. Basically, this is full marks. That's how you would do this. Now, they're saying C, calculate the distance that the block slides up the ramp before coming to rest. So what we want now is this distance. This distance is, in this case, our delta x. So we want to calculate that distance. So since in this case the only force that's doing work on the block is the parallel component of the force of gravity, on our equation of W net, we're gonna only have, we only need to account for the force for the work done by Fg parallel, because that is the net work done essentially. So W net is equal to delta Ek, right? Okay, and of course delta Ek is equal to 1 over 2 mv squared final minus 1 over 2 mv squared initial. And remember, this part that I'm writing here should be written below delta Ek, because to write the formula alone first to show that you are now going to be using the work energy theorem. We have the initial final velocity. We also calculated, we calculated the final velocity. We also have the initial velocity. We have the masses as well. The only thing that we need to find now is W net. But then again, look at this. we know that WFG parallel in this case is W net, right? So we know that WFG parallel is going to be equal to FG parallel, right? Delta x in this case is D cosine of theta. So the block, while moving up the ramp, the parallel component of gravity, of the force of gravity, is pushing against it. It's pushing in this direction. That's FG parallel, while the block is moving upwards and of course decelerating. So by the virtue of the fact that they are moving in opposite directions, theta is already 180 degrees because the angle between FG parallel and delta x is 180, as you can see here that with what I've drawn. And delta x, of course, is what we want to calculate. So let's rewrite this. And of course, don't forget that FG parallel alone is equal to FG sine theta. In this case, this theta here is not the same as this theta here. So this theta here is for this angle here, or that angle there. So it's sine 20 degrees. Let me write 20 degrees here. Now we're going to put this on this expression, on this equation, I mean. So FG sine 20 degrees. And then what is delta x? Delta x in this case is D multiplied by D cos 180 degrees. So now we can take the whole equation and put it here. So we will end up with something like this. Oh, by the way, cos 180 degrees is -1. So let's get rid of it now. And then we'll end up with negative FG sine 20 degrees multiplied by D. Cos 180 degrees has disappeared because it's equal to -1, and -1 will multiply to the whole expression. Will give you the same expression but with a negative sign in front of it. And of course, we're going to substitute our mass, which is 3 kilograms in this case, our final velocity, which is 3 meters per second squared, 1 over 2. Mass is 3. The initial velocity was 7 meters per second. And now we're going to try to solve for D. So we divide by this. And remember, let's come back to this side. Remember that Fg is equal to mg, right? So this is Fg is equal to mg, and then we are also dropping sine 20 degrees. Essentially, Fg is mg. So to calculate Fg, we just have to substitute 3 kilograms for the mass and multiply it by 9.8, which is the gravitational constant in this case, and have sine 20 degrees next to it. So here, this is the expression that we should have substituted, we should have written here, instead of having that Fg there. But it's not a problem, there's nothing wrong. It's just that we substituted a bit late, which is still okay as well. So what you need to do is to just say, in the place of Fg, you're going to write mg, but mg is 3 multiplied by 9.8. And of course there is sine 20 degrees. Sine 20 degrees multiplied by d is equal to, and if you look at this side, this is 3 times 3 to the power 2, which is 3 to the power 3. 3 to the power 3 is 27, so we have 27 here over 2. And 7 times 7 is 49. 49 times 3, so we have 1 over 2, and 49 times 3 here. And to get d, we just divide by the whole expression on the left as well. So we'll end up with 27 over 2 minus 1 over 49 times 3, and then we're going to divide this whole thing here by, you can just write it on your calculator as it is, 3 times 9.8 sine 20 degrees and of course this is the divide sign, so you might as well write it as a fraction. This part is pretty straightforward and you should be able to do it. So the answer we're going to get here is 0.91 meters. and that, or maybe any answer that's closer to it in terms of decimal places. And that's how you do this question. So we're going to be doing conservative and non-conservative forces in the next video. I hope this all makes sense. If you have any questions, you're free to inbox me. I mean, you're free to send your questions, or write them in the comment section. I'll attend to them as soon as possible. Thank you.